I'm now going to jump into the fun part, which is going through datasets that were taken with HBM torque cells and HBM eDrive motor analyzer. First, we will look at torque and an efficiency measurement. The setup for this test was a standard PWM inverter in a steady state torque and speed scenario. At the bottom, I have single phase voltage and current, just to give you an idea of what's happening at the terminals of the machine. On top, I have torque. There are two lines with two filter rates. The one that likely grabs your attention is the red line, which is the instantaneous torque that has cyclical peaks and valleys. We can use the instantaneous torque to get a power value, but typically what is desired from these efficiency scenarios is a good average that is on the same time basis as the average used for RMS voltage and current. Having a common time average for electrical and mechanical values gives us a good efficiency without inaccuracies being introduced from natural fluctuations of the system itself or outside fluctuations of a dyno. With the eDrive system, we do these torque averages on a per cycle basis. This meaning that every point measured from the torque sensor is summed and averaged over the time period of the fundamental frequency. This value is shown in the black on the top pane. This value is a static and likely what people are accustomed to seeing from a torque measurement. As can also be seen, the average value of torque is a static for the whole time period shown on the screen, or even if I scroll throughout the torque measurement. This is a cool effect of having a high bandwidth torque cell. Since we are sampling at a rate that encompasses the whole 6 kHz bandwidth of the torque sensor, we can get accurate averages of torque very quickly. This is because we are capturing every point throughout a cycle of the rotor, and we get a good average in a matter of rotation by picking up all those small nuances. This is opposed to other systems that I come across that sample more slowly and need long averages to get the same accurate torque average value, sometimes taking on the order of minutes. This is because they pick peaks and valleys and need a long period to accomplish the same task that we do in a matter of cycles. For average measurements, having a high bandwidth torque sensor and a high sampling rate from a DAC allow you to have both dynamic measurements of torque and very good average measurements quickly.